Hi, everyone. I'm very glad to be here with you and share this research. This talk is a bit different from maybe other talk that you saw. It's more red team oriented. So basically, if you're a pen tester or a red teamer and you're stuck on a target because they have implemented this kind of rule, I can show you tips that you can use to bypass this rule and adapt your tools and do whatever you wanted to do on the target. So who am I? So I'm Emeric Nasi. I live in Montpellier, south of France. You have the address of my blog and my GitHub page. And the tool MacroPack is a tool I use to automatically generate malicious payloads for Office scripts, shortcuts, etc. So I used it a lot to do the testings. This is a purely personal research. It has nothing to do with my employer. Okay, and as a part of personal research, I like to do research on Linux, Windows, IoT, and mostly weaponization. So what's attack surface reduction? It was introduced in Windows 10. I realized by speaking with the various people here that most of you don't know what it is. There's even someone who asked me if it was ASR, and no, I didn't forget a letter. So basically, attack surface reduction is potentially something huge. It's, most of the attacks that are going out there, they are not relying on 0 days. They are relying on some kind of phishing exploit. So using an Office document, using a USB key, using drive-by download. And the goal of Microsoft, I think, is to block entire category of phishing exploit using this. So it could be potentially huge and change the future of information security. The problem is the way that it's implemented, it's pretty easy to bypass, and some of the rules are broken. If you look at this talk was at BotConf last year, and to tell you how efficient ASR can be, the presenter explained, they show samples of all the macro malware-based campaigns, either for botnets or by even advanced persistent threat. And all of them would have been blocked by a single ASR rules. So ASR could be pretty powerful if it's implemented by Blue Team when they know about it. So the context of my study, so it was with the Windows Defender, with AMSI, and sometimes I also have to struggle to bypass the AMSI, with ASR rule, and well, I had a heavy usage of sysinternals and MacroPack. Okay. So now, for a set of rules, I will show you how they work and how to bypass them. Also, I hope you have nothing against VBScript, because that's the language that MacroPack generates, and but I think it's pretty easy if you want to translate the example in PowerShell or JavaScript. So block child process creation. So this is a set of rules which implement that, probably the most efficient rules. So when you enable this policy, you can prevent Office application to create a child process. Meaning basically, you prevent any kind of malware attack that's ongoing in the wild. You can also prevent Office communication, so like Outlook to spawn child process. You can prevent WMI and PSExec to spawn child process, and I think a lot of pen testers will not like that. And there's other rules like Adobe, but I'm not going to talk about them, but the bypass is pretty much the same. The thing with these rules is they are very powerful, but if you can bypass these rules, it's easy to bypass other rules because you can always drop an executable which does the work. So here's a typical example of an execution command inside VBA. And this is blocked by ASR, obviously, as well as a command function like shell execute, and DD attacks. So how to bypass this rule? Well, the important word is child process. And if you want to bypass this rule, you just have to think about ways to execute a command without using a child process. And for that, you have multiple solutions on Windows. So first, we are going to see some restricted bypass. So one way is to use WMI. So with WMI, you bypass the first rule. Well, this is not new, and this is already used in in the wild sometimes. The problem is this rule is blocked by the rule which blocks WMI. So it's only a partial bypass. Another partial bypass is using an Outlook object. So it bypasses the Office application rule, but it's blocked by the Office communication rule. So this doesn't work also. Now let's have a look at 3 examples of full bypass of these rules. So you can use the task scheduler. And this is what I thought the first about when I saw this rule. And basically, here in this example, I create a task which starts immediately and then delete it. And when you do this, the parent process is not Office. So it bypasses the ASR. Another example, you can use COM objects. So you need 2 conditions for that. You need to have a COM object with an interesting method like create object or shell execute. And you need this object to be loaded via another executable. So you need a local server 32 registry key. Okay. I created a PowerShell script to enumerate all the CLS ID in the registry and to find all objects which has interested methods. And which gave me some object that I could use to bypass AV and AMSI, not so much that I could use to bypass also ASR. One such object is a shell Windows object. This is not really new for the red team community. So you see that it has the local server 32. And here is a VBScript example of a command line with arguments, which bypass ASR and AMSI. And you can use from a script or JavaScript, VBScript or Office document. This is used also by red teamers because it's a DCOM, so you can use it for lateral movement. Something else we can do, since we can manipulate registry keys from the VBA, well, we can create a road COM object. So that's what we do here. It's just a false CLS ID. I create the right registry key, and when I try to call an instance of that object, it will automatically spawn the target that I put in local server 32, which is the program I want to run bypassing ASR. So another full bypass of ASR and AMSI. And this method, like the task scheduler, doesn't exist in the wild until now. There's always a risk to talk about this in public. So I will show only these 3 examples. I will talk about other rules now. But it's important to know you have a lot of other ways to execute without a child process on Windows. You could use COM hijacking. You could use URL schemes. You could use a lot of registry and file system kung fu and process injection. And so a lot of other possibilities. So now, next rule. Basically, this rule prevents the usage of a dropper. So imagine it could be potentially very big. No more droppers. You cannot save something on the file system if it's a script or an executable from an Office document. The problem is the way this rule is implemented, and it's based on extensions. So if you want to trigger the rule, which is funny is it's a kind of combination between AMSI and ASR. So for example, when I drop an HTTP file, it's blocked by attack surface reduction. And if I drop an exe, it's blocked by Office AMSI. So they have kind of combined together to block everything. The problem is, to bypass it, I just have to download the TXT file. And then I rename the TXT file to the real path, and I can execute it, and that's not blocked. So pretty easy to bypass. Let's look at another rule. Block Win32 API call from Office macro. So if you have been trying to play with the Meterpreter VBA payload, you notice that it's calling some commands from the Win32 API, some functions from Win32 API, and this would be prevented by this rule, for example. Now, this rule behaves a bit in a strange fashion. For example, if you have a document which is called Win32 DLL, you won't be able to open it. It's not just at the macro, during the macro execution it will block. You cannot just open the document. If the document is already open, you can execute the macro, but you will not be able to save the document. So when you think about that, you guess, okay, so this is static analysis, not dynamic. So you can find a way to bypass that easily. So if you want to trigger the rule, small example. Here I call the sleep function from kernel 32. And so this would be blocked by this rule. I will not be able to open the Office document. And if I want to bypass this, instead of calling kernel 32, I call k32.dll. And what is k32? Well, in fact, it's a copy of kernel 32. I put in temp. I move the current directory to temp, and then it works. ASR bypassed. So I think the rule is based on a kind of blacklist of names, and it's really not efficient the way it's implemented now. Also, something interesting, if you're into red team and you want to bypass antivirus and stuff, you don't need the DLL extension. So you can download an XML file and load it as a DLL this way. You can load your own DLLs this way also. Block Office application process injection. So if you want to test this rule, so for example, you can try a Meterpreter payload inside a PowerPoint document. So this is generated with MacroPack. It generates a reverse HTTPS payload inside the PowerPoint. And when I open the file, I click Enable Macro. It works. Basically, I have the session on the MSF console. But if I try to migrate to another place, now it's blocked. You see, operation failed, access is denied. So how do I bypass this rule? So I didn't take the time to see all the various process injections that I could have tested. The thing is, it doesn't really matter that I can bypass this rule. First, because, well, Meterpreter does spawn in the current application. So I can just run the Office application in background in a hidden. And then I get my session, and I don't even need to migrate. If I want, I can also drop another file which is not concerned by ASR, and pretty much bypass the rule. So I can do whatever I want with the Meterpreter. I don't need, I can just go around the rule. I don't need to destroy it. So now enough with Office rules, some script rules. So this is for JavaScript and VBScript. And it prevents them to launch downloaded executable content. And I must tell you, I had some trouble to trigger this rule. Because when you do, so this is a code of a classic dropper in VBScript. You see here, I call putty. I download it somewhere in TMP, and you see you have save to file, and then I run it. And this is blocked by AMSI. That's not ASR, that's AMSI. So first we need to find a way to bypass AMSI. And with the PowerShell script, you know, I told you about earlier, I found some object really useful to bypass AMSI. So here's an example. This is blocked by AMSI, but if I use this object, RDS data space, I have create object, which I can create a W script shell run, and this bypass AMSI. That's not detected. So now that we have the AMSI bypass, how do I trigger the rule? And I finally found out that, in fact, this rule only triggered with file with the zone identifier alternate data stream, which, in my opinion, is pretty useless because common malware, they use methods such as the one below, and this method doesn't leave alternate data stream. To have this alternate data stream, you need to download a file, for example, using a browser. So that's really not how a dropper behaves, and I think this rule is pretty useless. Anyway, if you still want to bypass the rule, here's some command line you can use to remove an alternate data stream from a file. Block execution of potentially obfuscated script. This again could be huge. I mean, you could prevent any obfuscated PowerShell, VBScript, JavaScript. And the problem is this rule is broken. It's really broken. I never managed to trigger it. So first I tried with the macropack obfuscation option. And you see that well, this is obfuscated. It's not the best obfuscation you can do, but you see that it's obfuscated. And you could detect it. I don't know if you measure the entropy of the variable names or the strings or something like that. But no, so not detected. And other common encryption were not detected either. And there was this article also by Doc Operator from 2017, where he tried everything, PowerShell stuff, and he never managed to trigger the rule. And in 2018, it was the same. So it could be useful, but I don't know. I don't need to bypass it because I don't trigger it. Okay, this one also could be a rule very powerful. What the description says is it could prevent execution of script and process from a USB key. So imagine a whole category of social engineering attack that would be blocked. The problem is, again, it's really implemented in a weird way. So I had some difficulty to trigger the rule again. I tried HTA payload, it didn't work. I mean, my payload worked, but not the rule. I tried VBS payload, I tried malicious shortcuts, I tried Windows binary, I tried non-Microsoft binary. And what finally triggered the rule if I have an unsigned binary or a binary with a bad signature. So for example, I append 0 to PuTTY. And this triggers the rule. So it's very limited in its functionality. And so it's pretty easy to bypass. So it works only for unsigned executable. And one easy workaround is to embed the executable inside VBS, for example. So you can do that with a single macropack command line. And when you play this command line, well, it will just extract the exec, put it on the file system, and run it. And this is not blocked by ASR. So pretty easy to bypass again. So I think this rule has nice potential, but the implementation is pretty much disappointing. I already talked about some of this, how to bypass. I wanted to focus on psexec a bit more, because I find something strange. If I run psexec -i, the simple command, that's not blocked. But if I try more advanced command, like the -s command to start a system shell, for example, that's blocked. And after some research, I found out that's probably the psexec SBC service which is blocked. So I don't know if you know how psexec works, but basically, in fact, psexec has inside its resource another executable file, which is a service. And when you launch an advanced command of psexec, like a remote command or this kind of command, it will drop this service executable on the C share, on the Windows directory. It will start the service, and then it will use this service to do the psexec magic. So a way to bypass this rule is to extract this service, to put it somewhere, for example, in TMP, to call it with the install option, to start the service, and then you can use psexec and it works. It's not anymore bypassed by ASR. So you see here I have my nice system shell. And if you want me to explain why this bypass the psexec, I'm really not sure. Especially I don't understand why there's this psinfo service which is run. So finally, so there are other rules, but almost at the end. So I did several tests where I created documents which could bypass all the rules. So for example, a malicious PowerPoint with an obfuscated macro which bypass ASR, AMSI, Windows Defender, and UIC, and downloads and drop PuTTY with elevated privilege. Maybe PuTTY was not very ambitious, but anyway. I'm not going to show all the code now. I just wanted to show you two snippets to show you how you combine ASR bypass and UIC bypass. So here, this is a code which call other execution function. Something that's interesting to know is that ASR error are caught by the error handling of the script, meaning that even if ASR is triggered, if you have this kind of error management, it will not hang the script. The application will continue to run. So basically here, first I try to execute with WMI. And if it doesn't work, I will try to execute with shell browser. And if it doesn't work, I will try to execute with scheduler exec. And the last two will bypass everything anyway. So now the UIC bypass. This is a new method I found like 3 weeks ago. And what's interesting with this method is it relies on COM hijacking, and it's fileless. So you don't have to drop DLL somewhere, and it's pretty easy to combine with ASR. What it does, basically, if you're interested, it's there's the control.exe process, which is vulnerable to COM hijacking because it tries to open this in the current user registry key. And the control itself is called by self-elevated sdclt.exe. So this is this UIC bypass. I did a write-up on my blog like 2 weeks ago. So how to combine with ASR? In the target path, so in the command registry key, I put the application I want to run elevated. And then I use my ASR bypass function that we saw in the previous slide to start sdclt.exe. And when you combine the two, then that's how I can get the elevated putty or elevated anything. And at the same time, bypassing ASR and also AMSI and antivirus. So yeah, this is the result. You see my putty, which was dropped by my dropper. And it's started with elevated privilege in French. So maybe I will put samples on GitHub, but I'm really not sure because I would hate to help ransomware writers. And if you saw the email I received since 2014 when I published the antivirus bypass paper, I really think twice before I publish something. So I'm still not sure what part of samples I will share. So other thoughts. So you see, I think ASR has a big potential. It could, like I said, change the future of information security by preventing all huge category of phishing exploits. The problem is currently the rules are really easily bypassable and some are broken. Something else, I found out that most people in Blue Team don't know about this rule. Maybe it's because it requires a Windows Defender, and people still think that Windows Defender is bad. And that's not my opinion. In my opinion, it has become a great product. And I think that more and more people will learn about it and maybe implement ASR, and at the same time, the attacker will adapt their code. Because currently, if you are you implement ASR in your company, you will probably be immune to any kind of Office attack, for example, because the attacker haven't adapted to it yet. So thank you, everyone. And feel free to ask any questions.
So I'm sorry, guys, since we're already 15 minutes behind schedule, would it be okay if we do the Q&A privately afterwards?
Okay, no problem.
So then we can continue with the next talk.
Okay, thank you.